One reason for IUPAC naming is because of isomers that are possible that lead to different structures. So these are all structures that represent hexane, and this is N-hexane, which is the straight chain version. Well, you've got these two on the right that are branched versions, where you have a 1-carbon branch off carbon number 2 or a 1-carbon branch off carbon number 3. This would be 2 1-carbon branches on 1 carbon in the main chain, and this is 2 1-carbon branches off the main chain off 2 different carbons. These are all 6 carbons. They all represent the same chemical formula, which is C6H14, but they have different structures. And because structures become so much more important in the functions, how these molecules function, we need some specific names for these.
So when you're given this name, 2-methylpentane, this starts by looking at this from the right side, which is the name ending ANE. So this name ending ANE means all single bonds. Okay, so now let's look at the next part, which is pent, P-E-N-T. So this part means that there's 5 carbons. That's the prefix indicating 5 carbons. YL is when you have a branch, and the length of that branch is what is attached to it, which is meth. So meth means 1 carbon. This number 2 is the location of the branch. And so then putting this all together, you're given the location of the branch, you know the length of the branch is 1 carbon, you know that the parent chain is 5 carbons, and that there are all single bonds. So you can build this, which starting with the 5-carbon parent chain, you have 1, 2, 3, 4, 5 carbons. Then you want to number this, and numbering the parent chain, you don't actually have to decide left to right or right to left. Since you're building the molecule, you get to just number it the way you want it. So I usually number left to right. This is anytime you're building something, you're making those decisions. And then the branch is off carbon number 2. So this is going to be a branch off carbon number 2. I'm putting it down, and it can be up or down. So it can be pointing up or it can be pointing down. It doesn't matter. The reason why I made it pointing down is because there's a 2 up there. But as long as it's on the correct location, and the correct location is by that number, which is carbon number 2, this one. So that is covering everything. I got the location, it's 1 carbon long, it's a branch, the parent chain is 5 carbons, and they're all single bonds. Once that's been covered, now you make sure that every carbon has to have 4 bonds coming from it. And every carbon having 4 bonds means that make sure every carbon has 4 lines. So there's 1, 2, 3, 4 lines, and those are going to hydrogens if there's nothing else specified. So this is 1, 2, 3 hydrogens that are added there. And they might be to other carbons. So this is 1, 2, 3 lines already off of carbon number 2. So add another bond for 4 lines, and that would be to a hydrogen. This branch right here, this has 1 bond coming out of it, so need to add 3 more, and then add those to hydrogens. And this is on carbon number 3. There's 1, 2 lines already, so add 2 more for 1, 2, and so that would be both going to hydrogens. This is number 4, has 1, 2 already, so I'm going to add 1, 2 more, and those are going to hydrogens. And this is on carbon 5. There's already 1 bond, so add 3 more, and those are going to hydrogens. So this is building the structure when you're given the name.